And today we will hear about forward mechanisms, about which ones are capable of full rotation and which are not, and that can be explored very easily and playfully in MechDev. I just create a forward mechanism of this type here, and of course I know that I have a constant drive input here. This moves around like this. In this case, the shortest and the longest link are both shorter than the two remaining links. You can see that quite clearly. I could also specify something else. I could display the path of this point, the path of this one, and of this one. And here you obviously don't see any path because those links are fixed to the frame. And if we look at these two here, the motion continues over to here. What we can actually see is that these two link lengths, in this case this one and this one, are shorter than those two link lengths. Only when these become larger than those two lengths, for example, when this length and this length are larger than those two, it will no longer work. We can also take a look at that by simply trying it out and seeing, aha, here it doesn't work, or here it doesn't work. That's why we have to change it, because for a mechanism to be capable of continuous rotation, we need Lmin and Lmax to be smaller than the other two link lengths. And you can see that very nicely and intuitively here. Then there's something else. There are certain types, namely two crank rocker mechanisms or double crank and a double rocker. Let's have a look. This is a crank rocker, and there should also be a second crank rocker. And if that configuration doesn't exist yet, we simply say, let's pretend we don't know. And we make this link here the fixed frame. And we can see that we now have a second crank rocker of this type. You may also know that if you make the shortest link the frame, you get a double crank mechanism. Oops, I've added a link. That wasn't what I wanted. I actually wanted to fix a link as the frame, and we can see that we now have a double crank here. That means these two links both rotate completely, so both are capable of full rotation. And now we have this link and this link, each as crank rockers, and that one as a double crank. And if we now make this link the fixed frame, then a double rocker will result, and this small link will be able to rotate about its own axis. We want to verify that by now making this link the frame, and when I do that, we obtain the double crank here. Very quick, very simple, and it's easy to follow what happens to the mechanism.